Okay, let's keep the recording. Guys, my Zoom session doesn't work today. In case you just plan to just log in, I had to just log in with my mom's account. And if you see a different name there, that's the reason. My account didn't work today. Now, today, we are going to continue with the trigonometric ratio. But today, before we introduce one of the most useful identities that it's going to haunt you even though at the level 5, when you just work with the integration, before we do that, I'm just going to start it with one question. And the question is that we are interested to find the cosine of an angle. And the cosine of the angle is going to be this. I'm going to introduce that using the radians because you learn how to just work with the radians. And you have to get used to that because from now on, all the way you just go to the level 5, you're just going to see J and Russell, just the radians one, not. Sorry, guys, if I just name the people, it's just, that's my habit. It doesn't mean that something is wrong. Then I said that. Then we're just going to get used to that, Michelle. With the radians, then as a result, I'm just going to introduce the angle as 17/12 pi. And I ask you something that's a very typical, for example, exam type questions. Find the ratio of an angle, which is expressed in radians, and somehow it is not as user-friendly as, for example, pi/3. Now, we are just going to find the cosine of this angle. And let me just put the question mark here to see that what we can do. Now, before we continue, let's see. I hope that everyone is taking notes. Yes. I think so. Yeah. Yes. Guys, please everyone make sure that you are taking notes. And Russell and Jayan. Everyone take notes. Thank you. And also you, Jayan. Open the Zoom on. Yes, is this Zoom? No, because I feel lobby, that's why I'm not. Now, in order to find this, somebody tells me, what should I do first? What is the best thing that they can suggest how to attack this problem? Any idea? 17pi/12, what is a cosine of that? What's the best thing that comes to your mind? The first and the most important strategy to solve it. Huh? Sorry, what? Fantastic. Is it for me? Good morning. Good, are you? Times 180 divided by 5. Oh, no worries, no worries. Okay. Now, the first thing that we have to do, if you happen to see that, when you come back from, let's say, the March break, and you see that on your test, the best thing that you can do, always remember your very best friend. You know what is your very best friend? That's the you. Let's call this Michelle. Not, I didn't mean you, that's the best friend. Now, what to do then, I'm just gonna construct a unit circle. Whatever you do with the trigonometry, for example, like this, you have to always start with the unit circle because it helps you to simplify the problem in a very easy way. And let's see how I'm just gonna use this in order to analyze this problem. Now, what we know is that this axis represents the x, projection along this represents the cosine of any angle, And this axis represents phi, which apparently any projections along that axis represents the sine of that angle. We have the origin of the circle and the Cartesian frame coinciding on each other, on top of each other, and the radius of the circle is 1. That's why this is called unit circle. The first thing which I'm going to do is that after I constructed that, my very best friend as a unit circle, I asked myself, I'm going to cheat a little. And in order to cheat, I said that, okay, let's have some point of reference on this unit circle, Russell. And I said that the point of reference on this unit circle is first, is going to be 0. That's the 0 angle. It's going to be 90, the one which is over here, but we are just going to be a little careful. I called it pi over 2 because we are in the habit to have everything in radians. This one is going to be pi, and this one is going to be how much? 3 pi over 2. And when we just make the full circle, and when we come back here, we see that this point here not only represents 0, it also represents 2 pi. Now, but apparently you know that these numbers which I have here is 0, 90, 100, 270, and 360. Now, look at this one. And now that's where I just want to do a little bit cheating. Sorry, it's a little bit in contrast to what you learned on assembly, that you should not cheat. I cheat in a very ethical way right now. It is not very bad. Look how am I cheating. I look at this one, 17 pi over 12. What is that? It seems that it comes from a different universe. I haven't seen something like that before. Yes, Lauren? It's very odd looking at it. Then in an ethical way to cheat is that I'm just going to look at it from the perspective of its degree. I say 17 over 12 pi. I know that I have to work with the radians, Jackson, but for this moment, I say that this is equivalent to 17 over pi times 180 degrees. Why? Because we said that, we learned that. Pi, if you translate it with the translator, you get 180. Then now, that's our ethical cheating. And we say that right now, 17 times 180. How much is that? You have a calculator, you put it, and you get the number. Then you divide it by 15. How much do you get? That's right. Yes, Michelle. Oh, sorry. Is it? It should be, sorry, it should be 12. Thank you. Good correction. Thank you. 12. Thanks a lot. Then how much did you get? That's right. We get 255 degrees. Then we see that, look at this. Then as a result, I can say 17 over 12 pi radians is equivalent to 255 degrees. That was our ethical cheating. Now, when you see this, it helps you now to identify which quadrant you can localize this angle. In order to show the angle that we are just going to work with, look at this. I'm not going to just find the localization. I say that any angles comes with two sides. The first side is going to be the one which is fixed. I put it just right on the x-axis from the origin all the way to the other side. The moving angle, it has to move, Jackson. And I have a convention that the movement is counterclockwise because I just want the angle to be positive. Now, the angle is 255 when I just did that ethical cheating. 255 is in which quadrant? Third, fantastic. Why? Because I remember that this one is 0, pi over 2. As a way to cheat, it becomes 90. pi is 180 degrees, and 3 pi over 2 is 270 degrees. And this one is also 0. Now, then as a result, as we mentioned, the moving arm of this angle should just land somewhere in the third quadrant. Now, lots of problem by this localization is solved just by as easy as that. Then you see that the angle which I constructed here, and you see that this is counterclockwise, is essentially 17 over 12 pi radians, or 255 degrees. This is very important. This first step is absolutely important. I call this point A. And we started from here, we constructed this angle. Any questions so far? You couldn't be happier, huh? Life is so good today, huh? Yeah. The prospect of March break. Now, guys, still, we haven't done anything, but this step is the most crucial step that we can think of as a strategy to tackle that problem. Now, what is the next step? We know that in order to find the cosine of this angle, what do we have to do? We have to have a projections from the tip of this angle all the way to where? To the x-axis. The length here from 0, the origin all the way to here, it gives you the cosine based on the definition that we have talked about the cosine. But the problem is that it's not that easy to get the measure, we get the tape, we get the ruler to find the distance from O to here. If I call that B, we cannot measure it. But what's the strategy to find this length to represent the cosine of 17 over 12 pi? It's absolutely impossible to figure this out. Minus pi. That's right. And as Kelvin said, we said that the reason that we are using, I should say, the unit circle is that we see that, guys, look at this step very carefully. We see the line OA. We see that what happens that we build this, for example, this one. We continue this line to all the way here. Because that's what we thought. And that's what we learned before. We said that anywhere that we are, we can continue from that angle to just go to the other quadrant. I remember I just used the word sling. You are building a sling. You remember that? And that becomes this point. If we started here from A, we end up with A prime. These 2 points are like twin brothers. And whatever characteristics you have for any of them is going to be valid for the other one, because we call that the symmetry of the unit circle that allows us to do so. Then I say that the angle which is built by having this red line crossing the unit circle at point A prime, building now this angle, which is still clockwise, and I do not know how much is that, I call this alpha, is going to be the twin brother of the angle, which is 17 over 12 pi. But how much is that, Michelle? How much is alpha? And Kate, please. How much is this angle alpha here? Calvin said, 17 over 12 pi minus pi. That's right. We said that. Liana, we said that we have this angle, we have this huge chunk of the birthday cake. We are going to cut the one above this. Look at this. Look at from A all the way to the A prime. You cut this part, this chunk. How much is that? Half a circle, huh? Half a circle, how much is the circumference of it? Russell? If the full circle is 2 pi, half a circle is how much? Pi. Then in order to find alpha, what do? I say alpha should equal the whole piece of the cake that we were offered. It was 17 over 12 pi And now we are cutting half of the cake from it, which is minus pi. And how much do you get? You get the common denominator as 12. You get 17 minus 12 becomes 5. Then you have 5 pi over 12. Then the alpha here, the twin brother that we are looking for, is 5 pi over 12. Anyone is good so far? Yes? Priyash, are they good? You're taking notes, huh? Fantastic. Any questions so far? Now, how many steps we have taken so far? We started with 17 pi over 12. The most important part, we constructed that unit circle. The second part, we had an ethical cheat. We find the angle is localized at the third quadrant. We use the twin brother using the symmetry. We localize it back at the first quadrant. And now the angle is instead of. And you see this? You broke the angle from 17 over 12 pi. You smashed it. You smashed it, and now you transformed it into 5 pi over 12. And that's the thing which we have done so far. Now, we do not forget that we are looking for the angle A. We are looking for the cosine. Then now we said that the cosine is going to be this. This is the cosine. Then we say what? We said that instead of writing cosine of why I cannot write anymore. Let me okay, now I can write over there. And now look at this. Now instead of saying, for example, define the cosine of 17 over 12 pi, now I smashed it and broke it into 5 pi over 12. Then these two cosine are the same. Then instead of finding the cosine of 17 over 12 of pi, I'm just going to find the cosine of 5 pi over 12, which is this angle, and it's represented by this projection. Now, again, you ask yourself, 5 pi over 12. How much degree is that? There's an ethical cheating here. How much is that? We say that 5 pi over 12, you multiply that pi by 180. You say it becomes 5 over 12 times 180. You get how much? Jackson, are you taking notes, please? 75. Fantastic. It becomes 75 now. Now, alpha here, 5 pi over 12 is 75. Now, the problem is now not to find the cosine of 75 or 5 pi over 12. We haven't seen that angle before, but we know that. Let me just go to the next page. 75 degrees is equal to 45 degrees plus 30 degrees. These are the celebrities, yes.
Shouldn't cosine of 17 over 12 pi be equal to minus cosine of 5 over 12?
We are getting to that. If you just hold on a second, because I'm going to introduce a formula, we go to that. Now, we said that 75 is equal to 45 plus 30. Now, from this stage, I know that 75 as 45 and 30, they are the celebrities of the trigonometry. I know the values for them. Then as a result, I can say that the cosine of 7, it was 5 pi. Cosine of 75 equals to cosine of 45 plus 30, or you can say that the cosine of 5 pi over 12 equals to cosine of pi over 4 plus pi over 6 radians. Now we are just going to start the new lesson right now today from there. So far, we reviewed something. Now, the new lesson starts from right now here. Now, we just want to find the cosine of sum of two angles. Now, welcome to Friday, new lesson of the day. And Nick, I'm just going to go to your point at the end when I find this one. That was the smart that you started from there. Now, what we did before, we said that if we have sine of two angles, sum of two angles, we developed a method for it. We said that it becomes what? Sine alpha cosine beta plus cosine alpha sine beta. And we said that if instead of adding, we have subtraction, I'm going to denote it by negative, by red color, then we end up with this cosine. Sine alpha plus minus beta, it's sine alpha cosine plus minus cosine alpha sine beta. That's the thing that we discussed about that extensively before. Now what we have here, the cosine. But what is the cosine of sum of the angles? We are not going to prove it at the ideal level, but we are just going to have the identity itself. It's like you just order the pizza. You do not just start from scratch. And now that's the pizza itself. And it says that the cosine of alpha plus beta equals to cosine of alpha cosine of beta. You see the difference so far? Minus sine alpha sine beta. If you compare that with the sine of the sum of the angles, you see that it's a little bit different. For two reasons, it's different. The products are all harmonized to be the cosine and sine. And if you have a plus, you have minus between these two expressions. And also, we said that the cosine of alpha minus beta, it's essentially like cosine of alpha cosine of beta, but because we have minus here, we get plus sine alpha sine beta. This is going to be the second identity that we learned. The cosine of sum of two angles. And be very careful. If you have the sum of the angles, you subtract these two products. If you have subtraction of two angles, you add these two products. Now, point 1 and point 2. We do not prove it at the ideal level, but we use the result as the way they are. Then as a result, we come back to the original problem. Original problem was to measure the cosine of 17 over 12 pi. We smashed it to the cosine of 5 pi over 12. And now cosine of 5 pi over 12, which is 75 degrees, as if it's the cosine of two angles, pi over 4 plus pi over 6. How to solve it? I use these two identities. Then as a result, we say that the cosine of pi over 4 plus pi over 6 let me go, sorry, it's not, I don't know why I cannot just write here at the bottom of the page. Let me bring it a little bit up. Yes, it becomes cosine of pi over 4 plus pi over 6 equals to, I use this identity, I use the first one on the top because this is plus, equals to cosine of pi over 4 You don't mind if I just go to the next page and start from the top? We said that the cosine of pi over 4 plus pi over 6 equals to what? Equals to cosine of pi over 4 times cosine of pi over 6 based on the formula that we had here. Is it going to be plus or minus? Fantastic, right? Minus, then sine of pi over 4 sine of pi over 6. Now, the rest of it is easy as a piece of cake because the rest of it is so easy. About the pi over 4, equivalent to 45 degrees, and pi over 6, equivalent to 30 degrees, they are the celebrities of the trigonometry, and we know their value. Yes, I'm going to solve it now because we have 2 more points to cover. Now, look at this. Cosine of pi over 4. You have, by now, you know how to, I barely memorize this stuff. I always reproduce them from the special triangles, which I'm going to do it right now again. But you may remember it's going to be square root of 2 over 2. But how to get to that point? We said that if this is, for example, pi over 4, which is 45 degrees, this is also pi over 4. The length is 1, the length is 1, its hypotenuse is square root of 2. Then you see that the cosine of pi over 4 is 1 over square root of 2 equals the square root of 2 over 2. Then the first term is going to be square root of 2 over 2 multiplies to cosine of pi over 6 or cosine of 30. How much is that? You may say square root of 3 over 2, but if you cannot memorize it, you're going to come to this triangle. Pi over 6 is how much in degrees? 30. You said 180 over 6 becomes 30. Then this special triangle, we have 30 degrees. And the other one, because that's normal, the other one is how much? 60 degrees, or pi over 6 and pi over 3. Always remember, the side adjacent to 30 is the square root of 3. The one in front of it, as usual, as the above one, is 1. And the hypotenuse is how much? 2, using the Pythagorean theorem. Then the cosine of pi over 6, which is equal to cosine of 30, is square root of 3 adjacent over hypotenuse, which is then is multiplied to square root of 3 over 2. So far, so good, everyone? Everyone is happy? How did I measure, Piyush, that cosine? Fantastic. Now, I have minus. Sine of pi over 4. Sine of 45 degrees. Look at these special triangles. you get the same result. You see that the sine of pi over 4 is again 1 over the square root of 2. It is the square root of 2 over 2. Then you get the square root of 2 over 2 for the sine. Then as you learn, for the angle, Russell, of pi over 4, which is 45 degrees, sine and cosine ratio are equal, and both of them are square root of 2 over 2. But how about Ash, sine of pi over 6? That's right. Thank you. Sine of pi over 6 is equal to sine of 30. Definition, Medina. How much is that? The definition. In front, the one which is front, how much? Fantastic. Thanks, Medina and Ash. And it becomes multiplies to 1 over 2. Then simplify that further. We have the square root of 6 over 4. We have minus, we have the square root of 2 over 4. We can rewrite it as the last version as square root of 6 minus the square root of 2 over 4, and we are done. However, we come back. Any questions so far, guys? Everyone is good? We come back, we notice that when we try to chop up, I should say, 17 over 12 of pi, we use this angle to find its twin brother. We saw that the angle which we originally started with, which is 17 pi over 12, or 255 degrees, Nick, is this measure is the cosine for it. But for its twin brother, the cosine, Lauren, comes on the right side of the origin of the Cartesian. Then it means that one of them, the original, I should say, the angle, the cosine projection is on the left side of the origin, which is, of course, is a negative number. But for its twin brother that we just expanded the line, the moving line, it ends at the first quarter, the first quadrant, which the cosine is on the right side of the origin, which of course is a positive number. Then we see that there is a contradiction. One cosine is negative, the other cosine is positive. What we measured right now here is this, the one on the right side, which is for pi over 12. But the original problem was what? To find the cosine of 17 over 12 pi, which stands on the right side. We learned that because of symmetry, these two lengths are equal, but because they are located on both sides of the origin, they are different just by a minus number. Then as a result, when we are here, we can finalize it like that. We said that the cosine of 5 pi over 12, we said that the cosine of 5 pi over 12 is equal to cosine of 17 pi over 12, but because they are located on two different sides, they differ only on the minus side. Then as a result, the cosine of 17 over 12 pi is minus the number that we got before, which is the square root of 6 minus the square root of 2 over 4. Just these two vary just by only one minus number. Do you want to go back to the previous slide, or this slide is fine? Now, I want to ask you to do something. The result that we just used that on the unit circle, because we had to just draw the unit circle, you see that, okay, the angle is on the right side, the other one is on the third quadrant. Oh, that's why they are going to be different by a minus number. You are going to prove it now. I just give you some time, Jackson, and everyone, to prove this one. to prove that the cosine of alpha minus pi, which we had it before, it's equal to what? Minus cosine of alpha. Now, let me just ask you to find it yourself. You just use the cosine law to find what we get from here. You look at the question. Everything is fine? Awesome. Of course, please. We have cosine of alpha minus pi. Imagine alpha was our original angle before. It was 17 pi over 12. We had to cut pi from it to get to the first quadrant. Using the cosine law, we get cosine alpha, cosine of pi. This is minus here. It means that I should just put what? Minus or plus? Plus, thank you. That we have sine alpha, sine pi. Now there are some of the terms here that are gonna vanish. What is the cosine of pi? Look at this. This is pi here. Cosine is a projection along the x-axis. Then the cosine of pi, it becomes minus 1. Then as a result, what do I get for cosine of pi is minus 1. What is sine of pi?
Why does it become alpha minus pi?
Sorry, what?
Why is it alpha minus pi?
Cosine of pi becomes minus 1. That's what you asked?
No, why is it
That's a question that we have to prove it.
Oh, never mind.
That's right. Now, how much is sine pi? 0. Then as a result, we say that it becomes cosine of alpha times minus 1 plus sine alpha times 0, which essentially gets you to the minus cosine of alpha. You see, that's the reason that we added minus there. As an example, you say that cosine of the thing that we did, the angle was 17 pi over 12. We had to subtract pi from it, as Calvin said. Then you see that if you follow the same identities that we had, you get with the minus cosine of alpha. And that was the reason that we added minus there. Then now we have a good intuition. Why did we add? We have to add minus there. Either geometrically, they are located on 2 different side quadrants, or if you use the formula, analytically, you can see that we have to present 1 minus there. Any questions? No? Everyone is fine? If you have no questions, let me recap what we did. Then we take the break, then we come back. How much time do we have today? 20 minutes. Awesome. Now, the problem was that, guys, everyone listen, that's a very important thing. Before we go for the break, consolidate everything that we did. Yes, Madina? Maftun or Medina? I always confuse with names. Medina, okay. Now, everyone got your report cards today? 4. Okay, now, look at this. What did we start? It takes 1 minute, but this 1 minute for the consolidation of what we learned is important. Everyone look at the board. We started by this question. What is the cosine of 17 over 12 pi? Our first trick was that we had to localize this angle on the unit circle. We had an ethical cheat to understand this angle is on the 3rd quadrant. At A, the angle is 0. At this is A, O, this is O. I didn't call this one. That called, anyhow, the angle is this. Now, we notice that the trick is this. We continue from this line all the way to the other line to just cross the circumference. Then we said that instead of working with 17 pi over 12, we subtract pi from it and we work with the 5 pi over 12. But the cosines are going to have different numbers. Then we notice that 5 pi over 12 is decomposed into 4 pi over 4 plus pi over 6. I use these identities for the cosine of some of the angles to find the cosine for this. And I use the special triangles to find the numerical values of these popular angles, which this is pi over 4 and pi over 6. And I just did algebraic explanations to reduce it. And also, we also proved this identity that the cosine of any angles, if you subtract pi from it, it becomes the cosine of the same angle, but you had to just introduce minus from it. Yes. Why did I put minus there? This one? Oh, you mean here, huh? Or here? Because cosine of the pi, if I go back to the unit circle, the pi is here, huh? The angle from O all the way to the pi. The projection of this angle on the x, how much is that? The projections of this angle on the x is this length, which is -1. That's why cosine of pi is always -1. Then I took this, I brought it here, and I put -1. Then as you proved it, the cosine of any angle, when you take out pi from it, it becomes the cosine of the same angle, but with the minus as a coefficient. Any questions? No? Then guys, please take 5 minutes break. Enjoy your break. Then I see you at 10:45. Okay, let me keep the recording on again. Now, okay, we have only 5 minutes to modify the identity that we learned. Then we are done for today. Now, we just started by this identity that the cosine of alpha plus beta is what? Is the cosine of alpha, cosine of beta, plus or minus here? Minus, that's right. Sine alpha, sine beta. Now, we ask ourselves, Lauren, you're going to ask me a good question. And the question is that, you ask me, can I possibly imagine that alpha is equal to beta? Was that your question? Yeah. Yes. If that was your question, then I'm going to rewrite it like that. Michelle, we ask this question as Lauren asked, then we say that then as a result, cosine of alpha plus beta. Michelle, can you please close the door? Sorry that I asked you because you're the closest one to the door. My very apologies. Then we say that the cosine of alpha plus beta, it's essentially like the cosine of alpha plus alpha. Then I'm just gonna apply the same identity that we learned, the cosine of sum of two angles, Angelique, to find that. Then we say that it's going to be the cosine of alpha minus sine alpha, We just started by our very basic Jackson identity that the cosine of sum of angles is this. And Lauren asked me what happens if I have two angles equal, then means alpha equal to beta, then we get this expression. Look at this. We said we have cosine of alpha plus alpha. What is that essentially? Cosine of 2 alpha, am I right? I have cosine alpha. What is that, Nick? Like A times A. That's 2 or cosine squared of alpha. Say that again. That's right. Or like this, we have A multiplied to A. We write A squared. I can write cosine alpha times cosine alpha. I can write cosine alpha squared, which becomes cosine squared of alpha. Then as a result, it's written as, guys, please listen. The sine squared of alpha. This is the first identity that is very important. Then we notice here that for the double angle, we can represent it by two expressions which expresses half of that angle. We start by the cosine of a double angle because it's multiplied by 2, but this is re-expressed as half of that angle there. Now, this is another identity. That's right. Cosine of 2 alpha equals to cosine squared of alpha minus sine squared of alpha. It is incredibly important. And now it's going to get even more important. Why? Because I go to the next page. I rewrite this identity that we learned that cosine of 2 alpha equals to cosine squared of alpha minus sine squared of alpha. So far, so good, everyone, huh? This is a very popular identity, but you remember the godfather of the trigonometry, huh? The godfather was this, that cosine squared of alpha plus sine squared of alpha is how much? 1. Now, the godfather sees one of its component here. Look at the cosine squared here. And we have cosine squared there. Then you wonder what happens if godfather helps me to express that term. How possibly, Angelique? We said that. We can write it like that. I say cosine squared of alpha is 1 minus sine squared of alpha. Am I right from the godfather? Then from here, I can rewrite it like that. I write cosine of 2 alpha equals to, I rewrite it like that. Instead of cosine squared, I write 1 minus sine squared of alpha. However, I still have minus sine squared of alpha intact. I rewrite it there. Look at this. I have minus sine squared of alpha minus sine squared of the alpha, which becomes how much? Minus 2 of that. Then as a result, you see that this one can be written like that, that cosine of 2 alpha is equals to 1 minus 2 times of sine squared of alpha. You cannot believe that. It's still myself on my work. I use that identity. That's a very important identity. Let me put that symbol there. It re-expresses the double angle with respect to the one angle or half of the angle, but in this form. However, any questions, guys, so far? However, Caitlin is asking me, what happens if I didn't want to use the Godfather like that? Caitlin is telling that, look at this. I have sine squared of the alpha, and I see the sine squared here. Why I didn't express that in terms of the sine squared? Then Caitlin is saying that I could have written sine squared of the alpha as 1 minus cosine squared of the alpha. Then, instead of substituting sine squared into this expression, I could put this one in there. Then what happens? That's right. Let me rewrite it here. We had cosine of 2 alpha equals to cosine squared of the alpha minus sine squared of the alpha. I'm going to rewrite it, Michelle, that cosine of 2 alpha, I write cosine squared of the alpha derivatives. Guys, please quiet. And instead of sine squared, I use the one which Caitlin proposed to do so. And I write minus, for the sine squared, I write 1 minus cosine squared of alpha. Now, you see that from here, you can write cosine of 2 alpha equals to, you have cosine squared of the alpha, you take minus inside the parentheses, you get minus 1 plus cosine squared of the alpha, which it gets you how much? 2 cosine squared of alpha, and you have minus 1 left outside, which it becomes another incredibly important identity. Yes, Jackson.
I thought the cos 2 alpha equals 1 minus 2.
Yeah, there are 2 equivalent ones.
Okay.
You can call this Jack. You can call this Pat. They are like 2 brothers.
Cos 2 alpha equals cos 2 alpha minus square alpha is the same thing as that?
That's right. Essentially, we derived 3 identities. The first identity was this. The second was this. And the third one is this. They are one of the most frequently used identities in trigonometry. Especially at the calculus level, you see that when you are finding integration of a squared function, you change them to the other format using these 2 identities. Any questions? Guys, remember, these lectures are recorded. Anything that you missed, you can rewatch it. Yes? Now, any questions, guys? Everyone is fine? And guys, yes.
Why would you, or the reason why you would use is to solve the inequalities or simplify?
And we are going to use them because like the screwdriver. In the future, we use them a lot like to open something. And guys, remember, guys, please everyone listen. And we are done. I have to tell you something. When we come back from the March break, you see that the exam is coming so fast. Then we just come back to the school. We still are so happy for the long break, and the exam is coming. I'm gonna, from the second week of the March break, I'm gonna put some very small stuff. I call that the breakfast of the day, for example. It's too small, one identity, and the solution is here. You don't spend too much energy to solve it. Just look at the answers and reproduce it. It helps you when you come back to the school after the March break. your brain is warmed up. You can come back with the same pace. If you want to do that, otherwise, neglect that and don't do that. It is for if you want to practice from the second week of the month. If nobody has a question, I wish you a very nice March break.